Welcome to the Real Python Podcast. This is episode 230. What are common issues with using notebooks for Python development? How do you know the current state, share reproducible results, or create interactive applications? This week on the show, we speak with Akshay Agrawal about the open source Reactive Marimo notebook for Python. Before writing any code, Akshay wrote a 2,500-word design document. He wanted to create a maintainable and reproducible tool that avoided the hidden state of traditional notebooks. We discussed solving the hidden state problem by building the notebook as a directed acyclic graph, or DAG. Akshay shares how Marimo notebooks are stored as pure Python files, which makes them easy to read, importable, and git-friendly. We discuss serializing package requirements using PEP 723 inline metadata to create standalone, reproducible notebooks. We also cover how Marimo notebooks can be deployed as a web app or dashboard using Pyodide. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Akshay. It's really cool to meet you.
Thanks, Christopher. It's really great to be here.
Yeah, I'm excited to have you on the show. I'm a big fan of data science and notebooks and so forth. And so when this project came across the transom, I was like, yeah, let's talk about Marimo and dig into it. So what I'd like to start with is maybe a little bit about your background as far as like using Python, not necessarily how you got into programming, but I'm always intrigued like how it's being used in universities and in those kind of cases. So maybe a little bit there and what you were doing recently before you started the project.
Yeah, definitely. Happy to share. So, interestingly, so when I did my undergraduate in CS at Stanford, I think now they do teach intro CS in Python, but back then it was Java/C++.
Yeah.
Yeah, I remember my freshman year, I was using Python for just like random side projects just because it was such a pleasant language to use.
Yeah, it's fun.
Yeah, I remember doing something silly like scraping a bunch of video game reviews to try and like figure out the historical distribution of game reviews on like IGN.com. I don't know. I did silly,
cool.
silly projects like that.
That sounds like serious research to me, honestly.
It was fun. But then I guess in university though, after I got through like the CS core, so I did like my main concentration was computer systems actually. So a lot of C++. But I also did like a math minor, and I guess basically CS plus math meant I took a bunch of machine learning classes.
Okay.
And so there, Python was always the language of choice for all the classes. So whether it was like things as simple as like using scikit-learn or using TensorFlow, or even just coding assignments in general where you had to, implement naive Bayes from scratch, like that was typically in Python.
And were you using notebooks at that time?
Back then, I'm trying to think. Once I got into like the machine learning classes, like CS 229 and stuff, like those had like final project components. And there, I was using notebooks for like training your models, plotting your loss curves, all those fun things.
From there, I don't know if you want to talk about like what your PhD was about.
Yeah, happy to. So I guess, so after I graduated, then I did a lot of Python work, probably the most Python work I did. So I went to Google and I worked on the Google Brain team for 1 year. And I was just thrown into a small sub-team inside of TensorFlow, the TensorFlow 2 team. I don't know, maybe there was like 6 of us.
Okay.
And we were transitioning TensorFlow from like the sort of static graph model to like the more imperative PyTorch style model. And so I learned a lot more about Python than I thought I would. And that was a lot of fun. Yeah.
Yeah.
But that was just a year. And then after that year, I went back to Stanford to do my PhD, which was in a mix of machine learning and optimization algorithms. And then there, I use, Python every day, and then also notebooks like almost every day. And I think for notebooks in particular, I think the reason I use them so often, me and like all my colleagues too, was that, when you're working with data, when you're training models, when you're developing algorithms, like it's very useful to have the ability to see your data while you work on it. You load your data into RAM. I don't know, you don't exactly know what the shape of your data is, so you slice and dice it in various different ways. You visualize it, or you compute various statistics of it. Then you prototype an algorithm, you run the algorithm on the data set, and then you're like, oh, that wasn't quite right. You tweak some code and you run it again. And then you have all these intermediate steps along the way. And if you were doing that in a script, you would just be rerunning like some prefix of code, which would just be wasted time, and it just wouldn't feel ergonomic. And so for that reason, because you see my data while I worked on it, I think we use notebooks really often.
Yeah, it makes sense. I feel that interactivity is, even at the base level of a Jupyter notebook, before we talk about the true interactivity and reactive stuff that's happening now, is just great. And that's, why they're so popular for experimentation. But there are lots of sort of problems that you can kind of run into, which we'll definitely discuss today. That, the problems with state and sharing them and that kind of stuff kind of gets to be a bit of the problem. But was it something where you would share what you were working on with other people inside the lab?
Yeah, our lab was, I don't know, kind of small. It depends on, we're like 8 to 10 people, but with our collaborators, we'd be sitting next to each other. So even like, you turn your laptop to the side and you show them your...
Yeah, check it out.
You show them your plots.
Yeah.
Yeah, so it was used for like a means of communication in that sense. Also for, I think, like commonly used for like producing tutorials or like examples in like open source projects. So in my lab, every research paper we did was accompanied with an open source, typically Python project or library. And so notebooks would feature as sort of example code. An anti-pattern, which my advisor really didn't like, which is when his students would like send him like an IPyYMB file, and he's like, in like an email, they're like, here are my results. He's like, what do I do with this? Like, he's like, I don't code in Python. Like I don't.
Yeah. Okay.
He's like, I don't know how to interrogate this analysis, let alone read this JSON file. And so we tried not to share notebooks directly with our advisor.
Would they have done just render it out then for them?
Like, you exactly render it out, copy the images out, etc., which was kind of a pain. And we'll get to this later, I'm sure. But like these days, I'm in touch with my old lab and some of the new students there. And they're telling me that my advisor says, like, come to your next meeting with a Marimo notebook, and because he wants to like tweak parameters and stuff and UI elements. So it's like kind of come full circle. He's like a big fan.
Yeah. Well, yeah, that true. In the sense that it can just be running in the browser. Is pretty cool. Yeah. Awesome. You mentioned in your email to me that you started to work on this project about 2 years ago. Is that right?
Yeah, that's correct. So basically, right after finishing my PhD. And so towards the end of the PhD, I think like every PhD student, I was a little bit spoiled. I got used to working on projects of my own, and I came to really enjoy that. So I decided I didn't want to go into academia. So I was trying to think, what should I work on next?
Is that like an excitement thing, or like you get to see the progress? What were the reasons there? You say it's selfish, but I'm sure there's other reasons behind it.
Yeah. I mean, for me, I think I just really came to like working on projects of my own, and in particular, like projects where you can step back and like rethink things from like first principles. I came to just really enjoy that process.
Yeah.
And like I mentioned during my PhD, like all of our research projects were accompanied with open source projects. And so between my experience at Google, where I worked on TensorFlow, and then in the PhD, where I became a co-maintainer of this project called CVXPy for convex optimization, I had spent a lot of time working on developer tools for people who work with data. I don't know. It's like machine learning people, data scientists, such a broad category of people that I have a hard time.
It's kind of wild how wide it is. I mean, Python might be, combined in that way. But I don't mind that term at all. People who work with data.
Yeah. And so like, I think for me, like the common thing that I noticed is that even though I had developed skills in applying machine learning and optimization to specific problems, what I enjoyed the most was building tools that empowered other people to solve their own problems.
Yeah.
And that was the part of the job that was really satisfying to me. And I felt like in that way, I could be more of a force multiplier. I could have a bigger impact. And after having worked on tools for specific sort of quantitative things like optimization and machine learning, I noticed that one area that I thought was overlooked was the programming environment in which so much of this work is done. So namely like the Python notebook.
Yeah.
And as much as I love Jupyter notebooks and I think they're a great tool, I think maybe because of the history where it was initially came out of the Python REPL project, I think they work well when, used for just exploratory tinkering, but not so well for things like reproducible science.
Yes.
Or like data engineering or things where you need like
or shareability in some ways.
Interactivity. So I started to notice like a lot of these sort of frustrations when I would work with notebooks on a daily basis. Like I would have like a co-author send me at the end of the paper, it's like, here are all my notebooks I used to produce the plots in the paper, and I would try to run them, and then they just wouldn't run. The packages weren't listed anywhere. There was no requirements.txt, and then more than that, like the outputs that were saved in the notebook would not match what I would get when I ran the notebook from top to bottom, because presumably the author of the Jupyter notebook, ran the cells in some arbitrary order and then commented out a cell and then ran another cell. And then at this point, it's like, I cannot reconstruct your execution history.
Yeah.
I felt like there had to be sort of a better way to do things. And so I started looking around, and I actually got a lot of inspiration from the Julia programming language.
Cool.
There's a phenomenal project there called Pluto JL. And the author of that, it's also a notebook. It's a reactive notebook for the Julia language. And the author of that notebook, his name is Fons. I think he did it while he was at MIT. And he noticed a lot of these similar problems too, regards to reproducibility, maintainability of notebooks, and shareability. And so he made this amazing notebook that was really gaining traction in the Julia language. And I sat there, I was like, we don't have anything like this for Python. And it sort of became clear to me that the way that I could, help a lot of people would be to invest in building a better notebook. And so that was 2 years ago, and happy to talk about the journey from there, but that's sort of where the seed of the idea came.
Yeah, that's great. We've talked about, maybe at the beginning of when I started the podcast, there was a study, I think it was JetBrains went through that collection of all the Jupyter notebooks, and it was over 50% wouldn't run. And, then you have the problem, like you said, with the results and so forth. And I think that's the problem with them in some ways is you don't know what history that whole thing has. I mean, was it truly like a notebook like you might have on your shelf that you jotted notes in, and it's just very random, like where you're kind of just like using it as a way to get your ideas down. But yeah, the idea of being able to jump around and randomly run cells and then trying to remember like what that is and so forth is always kind of interesting. We talked a little bit about it, the idea of this non-linearity of notebooks in general, but that kind of leads you to probably your first, I don't know, when was like the moment when the light bulb turned on, like, oh, we need to think about this differently and not think of it as a quote unquote linear progression, but more as, well, I guess you can explain it as a DAG.
Yeah, as a graph. I think there was a couple of, I'm not sure if there was any one moment for myself where I recognized that the DAG is the way to go, but I think it was sort of a building up towards that. So I think there was, we touched about on the problems of reproducibility with IPython notebooks, but I think in particular, there's two classes of problems, reproducibility problems that Jupyter notebooks suffer from. And one is package reproducibility, where, the author of the notebook won't document what packages they use and what versions they use, and then you can't recreate their analysis. And so that's separate, and maybe we can talk about that later. We have ways we tackle that in Marimo. But to your point of the other type of reproducibility, namely execution in hidden state. So I started experiencing these problems, and with hidden state in particular, maybe we should define that.
Sure.
In the context of a Jupyter notebook, it's this idea that the notebook has this mutable workspace of variables, and that is updated every time the notebook developer runs any particular cell, because they can just run like a REPL arbitrary blocks of code. They can mutate variables behind the scene. But then when the next person comes along to try and recreate the analysis, they don't know what code was run in order to produce sort of the output serialized in the page. And for that reason, a big problem in Jupyter Notebooks is that the code on the page doesn't necessarily match the outputs you see.
Right.
And one obvious sort of example of this, or like painful example of this, that really I think every Jupyter Notebook user has run into at some point, is that when you delete a cell, the variables are not actually deleted from memory. They still live in the kernel's memory.
Because they were run prior to that.
Exactly.
Right?
And so that means other cells that were using that variable just in some sense silently work, right? And like you may not realize that you deleted some data frame. You didn't realize that data frame was declared in the cell you just deleted, and you just happily go on, do your analysis, and then the next day, your 4 hours of work, and it's like nothing is working. You don't know why. So I think there was this recognition that, okay, there's a problem that code on the page is not matching the outputs you see. And then I think it wasn't a light bulb moment where it just came from my own idea. I think it was from my own brain, but rather it was more like a research process. So I mentioned that like I started looking for solutions out there, like have other people thought about this? And they have. And so in particular, the Pluto notebook, and then before that, observable notebooks from JavaScript, they took a step back and they said, you know what? It doesn't make sense. Like if a notebook is supposed to be a reproducible artifact, there should be only one way the notebook can be executed. And so they settle on this idea that like, well, if a cell declares some variables and you run it, surely it makes sense that after it's run, you want to run the other cells that reference those variables.
Right.
As soon as you say that, then the concept of a graph on cells emerges. And so the graph, has the cells are nodes, and there's edges between two nodes if one cell reads the variables that another cell declares. And you can trace this history as far back to the Excel spreadsheet. So it's not a very new concept, but one I think that we keep on rediscovering in the context of programming environments.
Yeah, I just had Chris Laffer on, and he's working on his own very interesting project called PySheets. And he's trying to do this sort of nonlinear Excel type of notebooks. His thing is like, it's not Python and Excel, it's Excel in Python, and the idea that he's going to kind of recreate this whole thing. But he's got the same kind of problem. Like the people that are used to working in Excel can have inside of a workbook multiple sheets that silently are referencing things on other sheets that you can't even really see. And a lot of that is done to do quote unquote magic, so that when you present it to the boss, they don't have to see all the underlying stuff that's happening. Maybe it's all the data is on pages behind things or formulas or whatever and so forth. So they can just look at the one main page and kind of see what's happening, which is really, really powerful, but it's confusing to kind of see. But that makes sense to me that it is very much a nonlinear, or whatever you want to call it, kind of way of kind of working. But there is a graph connecting all these things together and so forth, which is cool. So
in some sense, I think I might not even, for Marimo, I think the distinction between Jupyter Notebooks and Marimo is actually not necessarily nonlinear, but rather reactivity.
Okay.
So in a Jupyter Notebook, right, like you can run cells in any order you like, and the cells are really not related to each other in any way. You kind of implicitly assume or hope that the author of the notebook ran cells from top to bottom, but you don't actually know if they did.
Right.
In Marimo, the idea is that basically there's one main rule, and it's that when you run any one cell, all other cells that reference the variables it declared will run automatically or be marked as stale.
Okay.
And so that rule is imposed to ensure that the code on the page matches the outputs you see. So you can't get into weird indeterminate states. And that kind of like as a side effect or like a corollary of that, then you realize that like, well, if that's the way that cells are run, then it doesn't actually matter how cells are ordered on the page. And so you can have a variable that references a cell live above in the notebook to a cell that declares it. And then to your point, so then I think one thing that our users often do is then they'll put like appendix code at the bottom of the notebook, like helper functions or imports and things like that, so that things that they want to present to others are closer to the top.
Okay. So it can behave that way. Again,
it doesn't have to, and then it ends up being like a personal preference. Like I'll see users who still always write their notebooks in a totally top to down fashion, but others will try to organize it in a way that matches whatever they're trying to express best.
Yeah, I was noticing that as I was playing around with some of the examples online. I was seeing the buttons for moving cells around, which I wasn't as used to it being as visible, like a literally a drag button or an up and down button.
Yeah.
And in this case, theoretically, it doesn't matter, as far as where it is, which is cool.
Yeah.
Maybe we could talk a little bit more about, I guess, like what it is, because we were kind of discussing sort of like some of the minutia, like the detail stuff inside of it.
Yeah.
But like, what was your idea? Like, okay, well, what is this going to do and provide for people?
Yeah, definitely. So I think there was like 3 main design criteria that I had when I set out to build a new notebook. And to be clear, Marimo is built entirely from scratch. It doesn't depend on IPython or the Jupyter notebook server. And so these 3 problems that I wanted to solve can be like roughly 3 buckets. So one is reproducibility, which we've talked about at some length, in both code on the page matches the outputs you see, as well as packages ideally are also somehow bundled with a notebook. The second problem I wanted to solve was with maintainability of notebooks. So, there's this joke that like if you're a data scientist, like every folder that you work in has like some file called like untitled 57.ipynb, right? Like you just
right.
like you create all these scratch notebooks and like
it's the same in a lot of other creative industries, like new song 27,
exactly.
whatever.
Exactly.
final.
yeah, exactly. Final. Yeah, and I think like so. This is not really what like software usually looks like, right? But something is different about notebooks, and I think part of the reason is that Jupyter notebooks are stored as JSON files, not Python files, and so they're difficult to use as normal software. Like they're hard to version with Git because you get these huge binary blobs. You change some small amount of code, and then you get this huge Git diff, and that's not amenable to software engineering practices. And then also you can't really reuse code easily because again it's JSON, so you can't import the notebook easily. So I wanted to solve problems in maintainability. And then I guess the last class of problems I wanted to solve was in, sometimes I call it reusability, sometimes I call it productionizability. But basically, like once you have this notebook, like it would be great if it was not just a scratch pad that you just did once and threw away, but like you want to use it for real meaningful things. And in particular, I wanted notebooks to be able to be deployed as interactive web apps. So I wanted these notebooks, the Marimo notebooks, to have all kinds of cool widgets, like from the basic ones like sliders and drop downs, text inputs, to more complex ones like DataFrame transformers, selectable charts that were automatically synchronized with Python. So I wanted the notebook to have these things. And then also I wanted to make it possible for users to share their notebooks as interactive web apps, not unlike how someone might do with Streamlit.
Okay.
And so the sharing as apps was a big part. And then as well as executing notebooks as scripts. I wanted them to be sort of just regular Python software that could be used in pipelines and things like that.
This week, I want to shine a spotlight on another Real Python video course. It's titled Navigating Namespaces and Scope in Python. And it's based on a Real Python article by John Stearns. And in the course, instructor Johan Vergeer takes you through how Python organizes symbolic names and objects into namespaces. When does Python create a new namespace? How variable scope determines symbolic name visibility? And what is the LEGB rule? I think it's a worthy investment of your time to learn how namespaces are implemented in Python and how to navigate through the layers of scope in your Python applications. All the video courses on Real Python are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. So there's two areas I want to dive into. Actually, there's a whole bunch of them, but the two I want to dive in right away is like the package reproducibility part of it.
Mm-hmm.
So how did you tackle that?
So for a long time, we punted because I didn't know how to tackle that. So we released Marimo without any solution for that because, as I'm sure you and your listeners are aware, in Python, there's, like 24 different like packaging solutions, installers. It's just a really fragmented ecosystem. And it was really hard to figure out how to tackle this. But then there were two developments that made our life a lot easier. One was a new Python standard, PEP 723, for inline script metadata. And what that lets you do is serialize basically like a mini PyProject TOML almost as a comment in the header of a Python file. And so in that section, you can actually list, it's like valid to like list the dependencies of the Python script. And it just so happens, in order to solve maintainability problem of notebooks, we decided that Marimo notebooks should be stored as pure Python files. So we're like, oh, hey, interesting. We could maybe use this new standard to embed package requirements in the notebook file. And then the second development that helped was the development of the UV package manager by the company Astral, Charlie Marsh, and his team.
Yeah.
Because they went ahead and implemented the PEP 723 standard and made it possible to take a Python script that had its requirements declared in it at the top in a comment. And then with just one command, UV will create a virtual environment, the temporary one, install the packages from the script metadata, and then run your script. And it'll do that really fast because UV and everything that comes from Astral runs really fast. That's their whole MO. And so once those two things happened, PEP 723 and UV implementing support for it, we realized, hey, we can actually just, even behind the scenes, our users don't really have to know. We can just integrate with UV to provide this sort of package management experience for them. And for now, it's opt-in. So you download Marimo from PyPy, pip install Marimo, and then you create a notebook with a flag called -- sandbox. So you say Marimo edit -- sandbox my notebook.py. And then what that does is that opts you into using a package sandbox, and Marimo will statically analyze your code, figure out what packages you're importing, and then like save those to the notebook file, and then use UV behind the scenes to manage that temporary virtual environment.
So it's actually writing the PEP 723 style stuff into your, like the top of your notebook.
Yeah.
Because it's literally just a Python file, which is very interesting. It's actually very cool to look at it because I have opened up a notebook to look at the raw sort of JSON of it. And I agree that it's rather messy. And I could see how something doing a diff on it's going to have a total challenge. So those are very interesting things there. But I like the way it looks and the sort of the Python centricness of Marimo. And you using decorators, I think, is a really interesting choice for creating the cells. Was that something that you happened upon or just like seemed like an obvious solution to you? How did that come apart?
Yeah, so I spent a long time thinking about how Marimo notebooks should be stored on disk. I wrote this really long design document on it before I started implementing anything. So it wasn't obvious to me how they should be stored at first, but I knew that I had some criteria. Like I wanted the representation on disk. One, I wanted it to be so that whenever the developer makes a small code change to the notebook, it had to be that there was a small change to the notebook file. That had to be true, otherwise versioning with Git wouldn't really work. And the second was that I wanted it to be a pure Python file, of course. So I needed a way to delineate cells. And I think there was two options, basically. One is what you see in I think there's a name for this format, but I forget. But you'll sometimes see people using Python files for Jupyter notebooks. And what they do is they have these inline comments. Basically, you have a Python script, and then you have a hash, %% denoting a cell starting.
So it could be converted like a markdown kind of thing, something like that?
Yeah, something like that. The idea was that in this standard, it would be the case that you have a Python script, and then you just put some comments in there to say, to delineate sections of the script as different cells.
Okay.
I thought about doing that for the Marimo file format, but I decided against it because I wanted Marimo notebooks to be reusable as like regular Python modules. And in particular, I wanted you to be able to import a Marimo notebook and then reuse a cell or reuse a function from it without executing the whole notebook. So if I use the comment standard, then if you imported my notebook.py, it would just run your whole notebook and you would be sitting around waiting. So then I realized, okay,
yeah,
I need scoping. And the way you do scoping in Python is with functions. And then if you want to associate functions with some other object, in this case, like the notebook object, then you can roll them up using decorators. And so that's sort of how that came about. Marimo notebooks are still executable as Python scripts because there's a if name equals main guard at the bottom, and then it'll run. If you run it as Python my notebook.py, it'll run these functions in the right order to reproduce your notebook output.
I'm intrigued by the design document thing, and I wondered, have you done that before? Had you seen that before in like your PhD, studies or some other places where you're like, we really need to do this. We need to kind of have it all designed out before we really write any code. Like, I kind of want to know like your history there, like with the idea of a design document.
Yeah. So I guess, for context, I think I wrote like maybe 3 or 4 design documents before writing really any code for Marimo.
Okay.
I'm trying to, I'm looking it up. I have this repo, which
that sounds good.
I'm sure I'm the only person who has read this repo, or if other people have read it, they're really, very wonky because I call it MEPs, Marimo Enhancement Proposals. So there was 3 that I wrote, I guess.
Okay.
Actually, the first one that I wrote, the design document, was representing as a Python file.
Okay.
And then another one was how UI elements work in Marimo. So yeah,
we're going to get to that.
Yeah. So the history, I guess, is that I guess in my PhD, that was kind of the way that we did a lot of work of like,
okay,
you're trying to rethink something from the ground up, from first principles, and the most important thing to do is to come up with the abstractions. And once you have the right abstractions, then it's just a matter of implementation. And at this point, I was a pretty comfortable Python coder, and I knew like once I figured out what the thing was, I could code it. But for me, exploring the design space using English and Markdown and code snippets is sort of the easiest thing to do. And so
we had this recent episode where we talked about the danger of prototypes. I would argue, I haven't done the survey, but I would say that a larger percentage of people just jump in and start coding and build the prototype. They share it, it works and so forth. But their suggestion in the article was like, destroy the prototype then, completely destroy it, and then go to first principles and build it up. It's like, this is what they want to show people, like what is possible and what some of the ideas are and what it may look like, kind of way like maybe a web designer might create something in like a separate tool that isn't really web design and just show somebody what this would look like. But the tendency from management or whatever is to say, well, just use that. It works already, right? And it's like, no. And they don't understand all the kind of problems behind it. So that's why I find it intriguing that you were shown this idea of doing that. And I don't know how often that is, which is really cool because like it gets, like you said, the abstractions are there, the sort of extensibility, like, okay, I need to be able to make this so I can kind of grow this thing and grow this idea out.
Yeah.
Have you hit any brick walls in it that were like, oh, I got to make a left turn here? Or has it helped you by having all this design done in advance?
It's helped a lot having the design done in advance. I think with a project as I don't know, wide-ranging or as ambitious as Marimo, where we're like, we're taking something that people are very familiar with, the Jupyter notebook. It has a lot of problems, but, people have been using it for like 10 years now.
Right.
And so when we're proposing to do things differently, there's lots of ways that you can do something almost right, but then just like end up in some uncanny valley where like nothing works and people are really frustrated. So the main thing was coming up with like really simple rules that governed how Marimo works.
Yeah. And
I think those rules those sort of design pillars are still, they're the thing that makes Marimo what it is. And so I'm happy I put that legwork in.
Yeah. I'm trying to think like what to dig into next because there's so much there. Two of the things that I think are really cool, you mentioned sort of inspiration from Streamlit in the sense that the sort of interactivity and the dashboards and so forth. I guess where did you start with your ideas? Like, how do I wrangle that and make my stuff be reactive and interactive in a way? What was your approach there?
Yeah. So I think once you have reactivity, meaning like once you have almost the spreadsheet style connection between blocks of code, that opens up lots of different things.
Yeah.
And one thing that opens up is easier to use UI widgets. So in a Jupyter notebook, IPython widgets are kind of difficult for users to use because you have to like hook up these callbacks and you like scrub a slider, but like downstream things depending on the slider don't run automatically.
A lot of wiring you have to do.
Exactly.
Sort of code-wise.
A lot of wiring. But once you have reactivity, you have this ability of like, hey, like
the state is the state.
Yeah, the state is a state. And maybe like you can have a UI element hook into the graph itself and be like a way to basically control execution. And so this is an idea that I borrowed from Pluto.jl, actually. They had this beautiful API, which is a little different in Julia because they have like true macros and stuff. But they had this idea is like, hey, you can like create like, say, a slider or something and bind it to a global variable. And once that binding is done, then when you interact with, say, a slider, all cells that reference that, that variable, if you say x equals slider, all cells that reference x are going to run. And then all of a sudden, now if you hide the code, you basically have a mini web app.
Yeah.
And so Pluto didn't take it that far, but at the time I was looking at Streamlit and looking at Pluto, and I realized, like, if we support UI elements, if we just give our users, import marimo.mo, as mo.ui.slider, ui.table, we give them all these interactive elements, and if we just hide the code cells, all of a sudden they have a data app.
Yeah.
And not only do they have a data app, but they have one that's more performant than Streamlit is, because in Streamlit, you interact with the UI element, it runs the script from top to bottom. In Marimo, you interact with the slider, only the cells that depend on the slider are going to run.
It lights up those edges or whatever you want to call it.
Exactly, yeah. The inspiration came, I guess, both from Pluto and Streamlit, and seeing like, hey, notebooks and applications don't have to be these two separate things. You don't need, I noticed in like Streamlit repos, there would be like a app.ipynb and then an app.py. And I realized in Marimo, we can just collapse these things into just one notebook.py file.
Yeah.
So I had this idea. I'm like, okay, this seems like kind of interesting. And so I mentioned I started working on Marimo 2 years ago. And actually, it was over like a coffee with like a lab mate of mine who had then moved on to a Department of Energy lab, where he was asking me what I was planning to do after my PhD. And I'm like, I'm thinking about making this, new Python notebook that's more reproducible. It's more interactive with all these little widgets. You can make little apps. And he was like, oh, that's amazing. Like, my lab, we're a bunch of Pythonistas and scientists. We don't know any front end. We would love something like that.
Yeah.
And that's actually how Marimo originally started, and how I got to work on it sort of full time is that we set up like a contracting thing with Stanford's Linear Accelerator Laboratory, and they were Marimo's earliest champions.
They give you some support in some way too also?
Exactly, yeah. So financial support.
Nice.
And just as important, early users who were willing to eat pain and, try these prototypes. And, I had like a confidence that real scientists out here in the field are finding this useful.
Did you happen upon a specific UI library then that helped you with doing this?
So we use like a combination of a bunch of different front-end libraries. I started the project solo for a few months, but I was later joined by my co-founder, Miles Skolnick, who is a full stack and especially front-end guru. And so he's like totally revamped the front end since, what I decided to do.
I have a question on that. Is he who helped you do such a beautiful website? Because you guys have such a fantastic site.
he did make the website. Yes.
Yeah.
I think I have the design eye, but I am just so bad at, I will profess to be not good at writing JavaScript or TypeScript or CSS. It's just not my background.
It's so hard to combine them all together and then have an eye for it too.
Yeah.
It's like really kind of a magical thing. So that's cool. It's got a good partner there.
Yeah, no, he's amazing. He's the best partner I could ask for. So I think when I started, I was using just like native HTML elements for like the simple things for like sliders and text inputs. But then he pulled in other libraries for more complex. So like for example, one thing that we do in Marimo is that DataFrames, you don't just get like a HTML table, you get like a beautiful filterable, sortable, paginated table.
Something that's always been missing in notebooks. I'm sorry.
Yeah, no, it's amazing.
I was in an office that was using R and Python when I really got deep into, learning at the time both languages. And I just loved that about RStudio is like, I can just, okay, I want to filter, I want to do this, I want to sort. And it's like, I had to add all these extra things to be able to do that. So that's nice. Yeah.
Yeah. And so that for things like that, we didn't build it from scratch, but we used various React libraries that existed in the ecosystem. And then, we built our own plugin system to like interface the front end components with the Python on the back end so that the users never have to write any callbacks and just you interact with it. And Marimo knows how to match your UI element in the front end with the Python variable in the back end.
Nice. I love a lot of the built-in widget stuff. I was just experimenting with it and playing. And I mentioned to this right before we started, like just having a calendar widget is just like, oh my God, thank you. One that you can click on and it looks like a calendar and it's not like Apple's ridiculous design of scrollers and, that kind of stuff. Like, oh, you grab the day and because you don't have that year, you can't go to that day. I'm like, oh, come on. Just there's all these kind of goofy things there and the file selector one and really interesting ones. I mean, it'll be something fun for people to, explore the multi-select and the idea of like sort of collections of widgets that might go together in some ways.
And I think like one small thing that I've noticed is like, and I think is really core to Marimo is that you can use it for just notebooking as a replacement for Jupyter, or you can use it for building little mini web apps and internal tools. You can use it for or for both. And the cool thing is that these widgets are actually really useful in like both workflows. So obviously, if you're building an interactive web app or internal tool, you need some UI widgets.
Yeah.
But also, if you're just like doing data science or exploring new code, having these widgets lets you explore data in like new ways, in ways that really weren't easy or possible. Like, so in Marimo, like you can make a scatter plot with like Altair, and then you can like select a subset of the scattered points with your mouse, like just drag it over it.
Right.
And then you get the selected points back as a Python data frame. And now you can do more analysis. And that's like 2 lines of code in Marimo. And like, actually my PhD thesis was about like vector embeddings and then I would make up all these 2D plots, all these scatter plots of my embedded points. And then I didn't really know what I was looking at because it was just a static plot. So this is something I felt really passionate about, that like, data needs to be more tangible.
You're like, I want to click on that dot.
Yeah, exactly.
What is that guy?
Exactly.
Nice. Yeah, that's cool. So you could do that. You could click on that outlier or whatever, and it would, return something for you, which is really cool.
Yeah.
Yeah. Well, I definitely don't want, we have a limited amount of time, but one of the things I'm very excited about is what you're saying about a deployable web app. And to do that, was it early on, you're like, oh, I'm interested in using WebAssembly and the tools there. And then along with that, like, is this a Pyodide thing or like, what is it using under the hood?
Yeah. So that's a great question. Right. So like I mentioned, Marimo notebooks can be used just like you do Jupyter today, basically drop-in replacement. They can also be a drop-in replacement for things like Streamlit. You can say, instead of Marimo edit my notebook.py, you can do Marimo run my notebook.py to start a web server that serves your notebook as a read-only web app. And you brought up WebAssembly. So with Marimo run at the command line, that assumes a traditional client-server model where you have some server and some backend executing the Python code, and then you have some client that shows you the user interface. WebAssembly was not part of, I wasn't actually aware of Pyodide really that much when I first started the project. I saw some waves about PyScript, I think maybe 2022, sometime after I started the project. And that's how I learned about Pyodide. And Pyodide is a port of CPython that can run directly in the browser. So like just as your browser executes JavaScript, Pyodide can execute Python. And so we were, Miles and I we really wanted to make it easier for people to share Marimo notebooks and Marimo apps. And we're just 2 people. We didn't have, oodles of money to like give away compute for free like Google Colab does, right? But we still wanted to have like a website where people could just, play with Marimo notebooks. And so we learned more about Pyodide, and we were really impressed by like the breadth of packages that it supports, like NumPy, SciPy, scikit-learn, Matplotlib, DuckDB, and then it's growing. And so we gave it a shot. We're like, okay, like what? It turned out actually not to be that difficult to port to Pyodide. And so I think
that's great. That's good to hear. Yeah.
Yeah, no, it wasn't. And the Pyodide team is fantastic. Like they're so supportive. In fact, I'm meeting with them this weekend for like even we want to figure out how to make it even faster in the browser. And so they're really supportive.
Cool.
Yeah, so it was just part of our strategy to make sort of notebooks and computing more accessible to everyone.
Okay. You have a lot of examples on the site, which I think is fantastic, which is really great for people to try out. And when people click on those examples and they open up the Marimo notebook, if you will, you might see like a little hourglass, and that's dependent usually not on Marimo itself. It's probably going to be those Pyodide versions of packages that are coming in. Like you have a packages-in-Pyodide sort of listing of like, what's available there.
Yeah.
Is that kind of the experience, depending on how large those packages are,
Yeah.
is what's making it
Yeah.
take a little bit?
So the startup latency is like loading Marimo through Pyodide and then loading whatever packages your notebook uses, and then potentially like executing some of that notebook code before the outputs are displayed. Yeah.
I mean, if anybody wants to like balance that out, it's you mentioned this, speed of Astral and so forth, UV's tools. It's not that different in the idea that they're building, this virtual environment and loading all those packages and installing them. So this is a very similar kind of startup time, but this is entirely happening on the web.
Yeah.
Which is really cool. I mean, the idea that you can host just a file and people can go and check it out. And you don't have to have, like you said, some big cloud backend to do this stuff.
And what's really cool about WebAssembly and Pyodide is that once it's loaded, and maybe it takes 2 seconds or something, maybe a little longer to load, but once it loads, your notebook experience is very fast because there's no round trip to a server. So like you slide a slider and like you see things update immediately, and it's just such a pleasant experience.
Yeah, I mean, I've been impressed with that. So one of the things you mentioned there, you mentioned DuckDB, and I was wondering about what's your support for different databases. And I noticed that you had worked with the team at Narwhals there, and I had them on the show recently. What was it like working with them, and how has that helped you guys support different versions of DataFrames and so forth on the project?
Narwhals has been really great. So Marimo takes like, I guess, an opinionated approach to what a notebook should be. And one of that opinions is that Marimo is designed specifically for working with data. And so we have like deep integrations with like data frames from, like I mentioned, the rich data frame viewer, but also like we will automatically discover the data frames that you have in memory and then show them like in a side panel. Our AI assistant is aware of the data frames you have in their schemas. And so before Narwhals, we, and actually mostly Miles, he's sort of the owner of a lot of the data frame code in our code base, would have to basically build interfaces. And he was building a translation layer between pandas, polars, ibis, pi arrow, and like it was a big sort of maintenance burden and quite difficult to do. And then Miles found Narwhals, which basically does exactly that. It's this compatibility layer between all these different data frame libraries. Whereas with Marimo, we needed one, and we found someone basically working on it as their main project. And it basically, adopting Narwhals let us delete a lot of code in our code base.
That's nice. Yeah.
Get rid of bugs, increase our coverage of different data frame libraries. And so it's been really good. It makes it really easy for us to do things like, show column summaries as little plots in our data frame tables and all these things. It's been great.
Got a couple of questions about, you had a blog post recently as part of it. How do you take things from Jupyter to Marimo? What's that experience like? If somebody has an existing notebook, what can they do to move stuff over?
Yeah. So in order to convert from Jupyter to Marimo, basically after installing Marimo with pip install Marimo or UV pip install Marimo if you're using UV, after you install it, then at the CLI, we have an automated conversion tool. So you just type Marimo convert mynotebook.ipynb-o mynotebook.py, and it will do some automatic transformations to convert that JSON into a Python file. And it'll also do some smart code intelligence things to make sure it works in Marimo. So just one line. Yeah.
Nice. Let's say somebody does that. One of the things that we've kind of started with was this idea of state. And I love maybe the second tutorial, something like that. Like you kind of get into the weeds of like, okay, let's say somebody was doing experiments and they did reassign a variable in a separate cell. So now there's 2 references with assignments. And so suddenly it's like, well, which one should be which and so forth. And I noticed that it just sort of red flagged the cells, which I think is really a nice sort of visual indicator, outside of other errors that might run. I guess kind of what goes into that. And when I'm thinking about it, we have a course at Real Python here. If somebody's like really, really new to this idea, like they don't have a computer science background, this idea of scope.
Mm-hmm.
In the case of Marimo, there's this idea of generally of global scope, and you can only really have one reference to a particular variable. So am I explaining that right as far as like the experience somebody might have of moving a notebook over where it had that going on?
Yeah, that's correct. So basically, in order to use Marimo, like there's this contract that between you and Marimo, and the contract that you sign is that I will not declare variables multiple times across multiple cells. So each variable can be declared only once, and that is required in order to make sure that there's an unambiguous way that Marimo can execute your notebook. That I think is the biggest learning curve, but once you play around with Marimo enough, you get used to it. In terms of coming from Jupyter to Marimo, so that's actually something we handle for you. I mentioned that people don't run their notebooks from top to bottom order, but I think that's usually because they did something messy. But we assume that notebooks are meant to be run from top to bottom, Jupyter notebooks, so that when we do the conversion from Jupyter to Marimo, we basically statically parse the code in the Jupyter notebook. And if we find redefinitions of variables, we just uniquify them automatically.
Okay. Yeah, like a underscore or what have you or something?
Something like that. Like if you have like df equals blah in the first cell, and then df equals df dot apply transform or whatever, we'll do like df underscore 1 equals df dot apply.
Okay.
And so the semantics of the code are the same. It'll be a little bit more verbose because we've introduced new variables, but it'll work in Marimo.
Okay, cool. That's an interesting solution.
Yeah.
So you will get a warning if you try to do it if you're coding along. And so it's this idea that people kind of need to understand that each one of the cells can reference that thing, but inside of it, it's its own sort of enclosing scope. I don't know if I'm using the term right, inside of each cell. So like if you're going to do like I think one of your examples was like x plus equals 1 or whatever inside there, that kind of idea of an incrementer, it needs to be within that scope and not in a separate cell.
Exactly. Yeah. So if you're redefining a variable or like mutating in that way, you make sure that happens in one cell. Yeah, that's correct. Yeah.
Did I miss something I felt there was going to be a command for merging when I was going through the example, and I'm like, I don't see that anywhere there. And it's simply just the idea that you would just cut the code out and move it into the other cell, right?
Yeah, I think you would just cut the code out. I think someone had asked for that before and ended up prototyping or not, but we just said, copy the code out and merge them in. We have a command for splitting. I guess we don't have one for merging yet.
Okay, yeah. Well, I was just wondering that. I'm like, am I missing something here?
I think maybe part of the reason we don't, I don't know if I mentioned this explicitly yet, but so one thing that Marimo does, and I think it solves a huge headache, is that if you delete a cell, your variables in that cell are deleted from memory, and then all cells that use it.
And it runs again, kind of like we talked about.
Yeah, it'll run again and invalidate the cells that were using that variable. So
your state is updated.
Exactly, your state is updated. If we merge cells, then we would have to, I guess, delete both cells. I think there may be some surprising rerunning of code that we don't really want happening.
Yeah.
And I guess on that point, I might as well mention before we wrap up, a lot of people, when I start talking about Marimo, especially if they do heavy computation, they're like, oh, wait, your notebook runs cells automatically. I don't want that because I don't want to run a cell and kick off a long training job.
Yeah, sure.
I don't want to, or I don't want to run a cell and then accidentally charge $1,000 to my OpenAI, whatever thing. So if anyone is worried about that, we do have mitigations for that. In particular, you can change the runtime from automatic to lazy execution.
Yeah.
So that if you run a cell, instead of automatically running its children, it will mark them as stale. Meaning that you still get guarantees about the state of your notebook, but it'll just tell you, hey, all these other cells need to run when you're ready.
Is that done graphically at all?
It is. So the colors change, the output's kind of gray out, and then there's a button. Okay. There's a button and a hotkey to run all your stale cells to bring your notebook back up to date.
That's very much an Excel kind of thing, right? in a way that you're just because you could be touching like several things and you don't want it to recalculate every single time.
Exactly.
Cool. That's
Yeah.
great. Yeah, that's a smart solution. Gosh, it's just so much. I'm very excited. Might have to come back and talk about it more.
It is a challenge. There's so much to talk about Marimo that I'm never sure where exactly to dive into.
Yeah. Well, we're going to include lots and lots of links to it. I guess a couple quick ones. Do you have a favorite Marimo tutorial in your tutorial library that you want to share?
Actually, one that I really like that I did not make, but Vincent Wormerdom, who I think his Twitter handle is fishnets or something like that. He runs this tutorial website where he has tutorials for a bunch of different packages called Comcode.
Okay.
And at Comcode, he's made this really excellent Marimo course. It's like a sequence of like six videos, and where he'll use Marimo, then annotate his screen. It's like really great.
Nice.
So I love the Comcode course on Marimo. Marimo does come packaged with tutorials, like Marimo tutorial intro at the command line will just open your tutorial.
Yeah.
I like the intro one. It's simple and it shows you like everything you need to know about getting started with Marimo.
It was a good tour for me to get my feet wet and familiarize myself and just start playing with it, which is great because of the interactivity. Are there ones that you want to add to your tutorial library that you think are missing?
Yeah, I think we cover the basic concepts of Marimo well, including, which I didn't even mention, that we have like built-in support for SQL cells too, which is a whole other, that could be a whole other podcast on how you merge the Python graph and the SQL graph.
Yeah.
But actually what I would like to see more of is like people using Marimo to make tutorials about other subjects. And because I think the interactivity that Marimo brings like really lets you teach concepts in new ways.
Yeah, think about like math. Like you said, you have some background of that. Like that idea of like being able to play with it. Yeah,
exactly.
Or just even code. Yeah,
exactly. Code and math. And so I would love to see like a series on probability, on linear algebra, machine learning. I think it would be really compelling.
Yeah, awesome. So I have these questions I like to ask everybody who comes on the show. And the first one is, what's something that you're excited about that's happening in the world of Python?
I'm really excited about improvements to CPython, actually, that are coming downstream. So both like the JIT that's been working on for Python performance, as well as I'm really excited about a future in Python where we don't have a global interpreter lock. I think the ability to just use threads and not worry about a performance hit will really make a lot of things much easier, especially in like scientific computing, because like sharing memory between multiple processes is kind of difficult. So if there's a future where I can just spawn threads and just go to town, like I think that would be really exciting.
We didn't get into it, but what versions of Python is supported with Marimo?
Marimo supports 3.9 and above.
Okay.
We were supporting 3.8 and above for a while. We just dropped it because 3.8 reached the end of life and is no longer getting security updates. So we're like, okay, we probably don't need to support it anymore.
And how's working with 3.13?
It's been fine. Like I think like performance is somewhat better, but we haven't gotten any complaints that it's not working. So I think that means it's hopefully working.
That's great. Awesome.
Yeah.
So what's something you want to learn next? That could be, outside of programming, could be just something in your life you want to learn.
Yeah. Outside, so I spend a lot of my time on Marimo, but outside of Marimo, one thing that I've been meaning to do, and I did a tiny bit of, but I haven't done much. I'd like to learn how to sketch, with pencil. I have this notepad where I did a few sketches a number of years ago when I was, I think, in my PhD. But there's something about more than even just like the act of just drawing, but like I want to teach myself to be better at just observing the world around me. And I think like that's the thing that I noticed that I really liked about sketching. Because like the hard thing is like not necessarily the manual strokes with my hand, but it's like, wait, what is the image that I'm trying to capture? And like I hope that it'll help me become more mindful. And
I did a little bit of that. I studied engineering very early on, and then completely went into the music route. But there was a course that I took that was on sketching, and there's a lot of interesting techniques of like almost sort of masking out the entire picture and just working on a small thing, and focusing on that.
Mm-hmm.
They started the semester with do a self-portrait, and and then kind of like you would do at the end, and you kind of be able to see what you were doing. And you did a sort of a set of those. And it was kind of surprising because like your brain takes over and you just start doing things that you think are there, these sort of weird assumptions about what should be drawn, and they're all just wrong. They're just like your brain has like been wired in a weird way, and so it's a very interesting process and very, very methodical to like rewire your brain to do it. So I would like to get back there too.
Amazing.
I enjoyed it, but yeah. What's the best way people can follow not only the project but follow yourself online? How can people follow the work that you do?
Yeah, so let's see. The project has a Twitter account. We're marimo_io on Twitter.
Okay.
Obviously, we're on GitHub, marimo-team/marimo. To follow me, I'm on various socials. I think probably the easiest thing is to go to my personal website, aksayagrawal.com.
Okay.
First name, last name. And then I have links to my Twitter and my LinkedIn and my personal blog, which I have not updated in 4 years. But yeah.
Okay, cool. Well, Akshay, it is really fantastic to talk to you, and I'm very excited to see what happens with the project.
Thanks, Christopher. It was a pleasure to be here.
I want to thank Akshay Agrawal for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.